All right, so before I can do shorthand notation, I think it's a little helpful if I show you a little trick that's on the periodic table. And so I wrote out the electron configurations for the first 16 elements, right? And just notice that as you go down, all we do is we add something. But like, so 1s1, 1s2. Notice lithium still has the same thing helium had, but then continues on to 2s1. Beryllium builds off, and then boron has the same thing as beryllium, but then adds up. And so we have this nice little pattern. All right, this ties to the periodic table really well. The periodic table is arranged in increasing proton counts, and so also increasing electron counts. It's also got another part that's really nice, and that's like when we look at it, it actually kind of reads the electron configuration to you. We have some blocks that we like to look at, and so this first one is over here. This is what we call the S block. And then this green box, oh, okay, helium goes in that box, so just use your imagination, pretend it's over there. This green box over here is our P block. This middle one is our D block, and then this purple block down here is our F block. Right, and then our rows in our periodic table actually correspond to energy level. And so we have energy level 1, 2, 3, 4, 5, 6, and 7. All right, and so as we're going across this, we're increasing how many electrons we have, and so we're making progress through our sub-level energies and our energy levels. So right here, hydrogen, it's 1s1. Notice it's in the first row, and it is the first sub-level, and it puts one electron into that S sub-level. Right? When I go on to helium, helium has 2 electrons, and so we filled it as 1s2. Well, I'm in the first energy level, and I'm in the second box of my 1s sublevel. Right? Going on to lithium, lithium fills the first energy level, and then it starts energy level 2. And this is the first element in that second row, and it's in the S block. So I have 1 in my S block. Right? If I go down to beryllium, beryllium fills the whole first energy level, and then it has 2 electrons, and it puts it 1 in the S block and then another 1 in the S block, and so it's 2s2. Right? Boron fills the first energy level, so we got to there, and then it puts 2 electrons in the S orbitals, so it put 1, 2 into S, and then it puts 1 into the P sublevel of the second energy level. All right, and then carbon is next, and so it puts 2 electrons into that p orbital, and then nitrogen puts in 3, and then oxygen 4, and then fluorine 5. And so notice this is telling us how many electrons, if we count those blocks, like fluorine had 5 and 2p5, it put in 1, 2, 3, 4, 5. Neon puts in 1, 2, 3, 4, 5, 6. All right, and so if we were looking at something like aluminum, aluminum fills the first energy level, 1s with 2 electrons, and then it fills 2s with 2 electrons, and then 2p with 6, and then 3s with 2, and then it should put 1 electron in the 3p orbital. And looky there, it sure does. And so this is a nice little cheat. The one thing you have to remember is that some of our energy levels overlap. And so when you're doing 3p, you jump down to 4s, and then this is 3d. So our d energy levels are a little bit higher energy than the s before it. And so you just have to remember that when you get into this little magical fairy zone right here, that you jump down in energy level. And then right here, you jump down to here, and that's your F orbitals. And so you have to, it's like a super magical fairyland where you have to jump down 1 more energy level. And so you go from filling 6s to filling 1 electron in 5d, and then you fill your 4f. So you just have to remember to jump down 2 energy levels from 6 to 4. So anyways, you can use this. This is just kind of nice because when you're going across a periodic table, you can just go, oh, 1s2, 2s2, 2p6, 3s2, 3p6, and you can just write it really quick, and you don't have to look at our little chart diagram that we drew with diagonals. All right, but what I'm really after then is shorthand notation. And so shorthand notation uses the noble gas beforehand. And so let's say I wanted to write the shorthand notation for, let's do, I guess we could do ones that we have already done, like let's do beryllium. Beryllium we had as 1s2, 2s2, right? And so when we're doing shorthand notation, this one's not going to be too exciting. What we're going to do is we're going to find the noble gas that comes before our element that we're looking at. And so noble gases is this last row over here. And a lot of you should know that, I would hope. So beryllium is right here. And so if I go backwards and I find the noble gas that's before it. So I don't want to come to neon because neon is 10, so that's after 4. I want to go to the one that's before it. And so I'm going to go to helium. And so what I'm going to do is I'm going to say, hey, beryllium, it's just like helium, except there's more to it. And so I'm going to say it has the same electron configuration as helium, but then I fill 2s with 1, 2 electrons. And so it fills 2s2. All right, and so let's look at one that's a little bit harder. So we did phosphorus. So phosphorus had 15 electrons. I'll put that up here so that we can kind of see it. So we're doing phosphorus. Phosphorus on our periodic table is right here in 15. So again, I want to find the noble gas that comes before it. So I don't want 18 because that's after 15. So I'm going to pick the 10. And so I'm going to use the noble gas of neon, or the electron configuration of neon. All right, and then all I'm going to do is write the stuff that comes after neon. And so after neon, I have 3s2, and then I have 3p, and I have 3p, 1, 2, 3 to get to phosphorus. All right, and so again, this is the same thing we had written up here. And so all I'm doing is I'm saying that neon's noble gas configuration is this. And so I'm putting in neon in brackets just to represent this. And so that's what makes it shorthand, is as I'm shortening it by using my noble gases. So let's look at manganese. Manganese is right here. And so the noble gas that comes before it, I'm going to go up a row and go to the end. It's argon. And so what comes after argon till I get to manganese would be 4s2. And then it jumps into 3D. And so it's 3D, 1, 2, 3, 4, 5. And so again, this should match. Yes, it matches our tail end right there. So, oh, sorry, you can't even see that. So again, this part matches that. And so this argon is just representing all of this front mess. And so this is shorthand electron configuration. Okay. I will do this long one just for good practice. So here's tungsten. Tungsten is 74, and so I'm going to go up a row, clear to the end, and I'm going to find it to be xenon is the noble gas that we are using. And so it's 50, oh, xenon. Right, and then I'm going to use everything that comes after xenon until I get to tungsten. And so I have 6s2. And then Ooh, 5D1, because it puts 1 in that 5D. This is a little bit confusing. If you grouped it all together later, it would be okay. And so then it jumps down and it fills 4F, and it goes all the way through this because this is 71 and I have to get back up here. And so it puts 14 in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then it jumps back up and it fills in 5D again, and it puts in 1, 2, 3. Now again, if you weren't using the periodic table, you could definitely go xenon fills 6s2, 4f14, and 5d4. There's nothing wrong with this. It just combines these d orbitals. It's not necessarily exactly how it fills, because it does fill that one electron in the d orbital first, but that is okay. And so again, this should match the ending part. So here it is, 6s2, 4f14, 5d4. And again, 6s2, 4f14, 5d4. And so this is how you write shorthand electron configuration. Right, I know that that might be a little confusing for some of you. There's tons of YouTube videos that could possibly help you if you didn't understand what I was saying, or also you can jump onto the Zoom session and ask me for some help. But hopefully it wasn't too bad, and hopefully I do see you all later for the Zoom, but if not, have a great day.